We're going to look at one last way to graph called using slope-intercept form. Slope-intercept form is y equals mx plus b. The reason they call it slope-intercept form is because the m and the b stand for the slope and the y-intercept. We'll start, before we graph, with just an example of identifying the information. So in this first example, we have y equals 2x plus 3. We're going to compare that to y equals mx plus b. And we want to figure out, when we compare our problem to the formula, what number did they put in for m, which is the coefficient of x. So right in front of the x, they put in a 2. And then we also want to figure out, what did they put in as the constant? So the number that doesn't have an x next to it. In this case, that's the 3. So the b is 3. So the slope is 2, the y-intercept is 3, which we would also write as an ordered pair, 0, 3. The way that this can get a little bit more complicated is if they don't give you the original problem in slope-intercept form. So remember, it's supposed to look like y equals mx plus b. And 4x plus 2y equals 8, that's in standard form rather than slope-intercept form. So what I would have to do is I'd have to use inverse operations to solve for y. That means I'd start by subtracting 4x from both sides, which now gives me 2y equals 8 minus 4x. 8 and 4x are not like terms, so I can't put them together. That's as much as I can do there. And then I still don't quite have the y by itself yet because of the 2, so I'm going to use the inverse there and divide both sides by 2. 2 divided by 2 is 1. 1 times y is y. And then here, think of this as like two separate problems here. It's like 8 over 2 minus 4x over 2, and then we'll reduce those. So 8 over 2 is 4, and 4 over 2 is 2. So here's my equation. It's probably a little bit easier to rearrange it so that it has the m part first, y equals mx plus b. We've done this before. Remember thinking of the subtraction as a plus negative, and then it's a little easier to see that this would be negative 2x plus 4 using the commutative property of addition. So now it's a little easier to see because now it's in the correct form. The number in front of the x is the negative 2, and that's your slope, and the number in that doesn't have a variable next to it, the constant, that's the 4, that's your b, that's your y-intercept, or in other words, this y-intercept would be the point 0, 4. To graph a line in y-intercept form, you're going to first make sure it's in y-intercept form. So in this case, we'd need to subtract 3x from both sides, and we would get y equals negative 3x plus 2. And then compare that to our formula, y equals mx plus b. And now we can see a little bit more easily that the m is the negative 3, and the b is the 2. Or in other words, that y-intercept is 0, 2. So to graph these, what we're going to do is we're going to plot the point on the y-intercept first, so 0, 2. And then we're going to use the slope to get more points like we did in a previous video. Now, what's a little different about this one is that negative 3 is not rise over run like we're used to. So we're going to change it to negative 3 over 1, which is equivalent to negative 3. And then if I make that my rise over a run, my rise would be -3, which means down 3, and my run would be 1, which means right 1. So from the point that I already made with the intercept at 0, 2, I'm going to go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. And then remember, you can also do the opposite direction. So instead of down 3, right 1, you could do up 3, left 1. So I can keep going up 3, left 1. Up 3, left 1. And then connect those points with a straight line, remembering the arrows at the end since they go forever in each direction. And then one last thing before we call it a day here. One last definition of parallel lines. Parallel lines, you probably recall, are lines that never intersect. But a way that you can tell that lines are intersect is if they have the same slope. So if one has a slope of 3 and the other one has a slope of 3, then that means that they are parallel. So a possible example here, I could give you something like y equals -2x plus 4. That has a slope of -2. And y equals -2x plus 8. That has a slope of -2 as well. Now the y-intercepts do have to be different because they are technically two different lines, not the same line. But these two would be parallel because they have the same slope.